This is number 5 in the 2023 AP Calc BC free response question part of the exam. This is on area and integration and all that. Okay. So they give us that the graphs of f and g are shown in the figure. X between 0 and 3 is known that g of x is this guy for x greater than or equal to 0. A twice differentiable function f, which is not explicitly given, satisfies f of 3 is 2 and integral from 0 to 3 f of x dx is 10. Find the area of the shaded region enclosed by the graphs of f and g. Okay, so area is upper curve minus lower curve. The upper curve here is f of x clearly. The lower curve is g of x. The limits of integration, they're from 0, they intersect at 0. They intersect as well at x is 3. So integral from 0 to 3 of f of x minus g of x dx. That's the setup. Okay. Now, how do we evaluate this? Well, we can use properties of integrals to break it up like this. Okay. They tell us that this is 10. This guy, we know how to integrate. This is just natural log. Okay. 12 is the constant, so I left that alone. This becomes ln of absolute value x plus 3. Evaluate from 0 to 3. And then this should be the final answer. Don't bother simplifying. Leave it like this. You could simplify, but there's always risk at simplifying. They don't take off points if you don't simplify this. So leave it like this. Okay, so that was part A. Part B, evaluate the improper integral or show that the integral diverges. Okay, so we got to have proper notation here. Notation is half the points. Okay, you got to change it to a limit. So this is the improper integral in question. We change it to limit as I chose the variable as t. In the scoring guidelines, they use b. You can use whatever variable, doesn't matter. T approaches infinity, integral from 0 to t. And then I squared this, so that's 144 over 3 plus x squared. Okay, 144 is a constant. I moved that out front. This 1 over 3 plus x squared, we could do a substitution. This is hopefully simple enough to do in your head. The scoring guidelines don't say you have to explicitly show the substitution. Okay, so it is minus 1 over x plus 3. We evaluate from 0 to t. Okay, do the fundamental theorem calculus. By the way, this minus sign is a constant. I pulled that out in front of the limit. Okay, now this is after fundamental theorem calculus. As we approach, t approaches infinity, this guy goes to 0. This is a constant, so it remains. Multiply this and this. You get positive 144 over 3. That's what the improper integral converges to. Okay. Part C, let h be the function defined by h of x as x times f prime of x dx. Find the value of integral from 0 to 3 h of x dx. This is a big clue right here that maybe we got to use integration by parts. Okay, so we let u be x, du is dx, dv is whatever is left in the integrand, v is f of x as a result if we integrate. Okay, how do I know to choose this? Well, we probably need to use this piece of information over here, so we need to integrate f prime to f. So we don't want to let u be f prime, du is f double prime. We're giving no information about f double prime here. Okay? Except that f is twice differentiable, so f double prime exists, but no other information given. Okay? So we do integration by parts. That's right here. They give us, this is 10. This we got to do fundamental theorem calculus. So that's 3f of 3 minus 0 times f of 0. F of 3 they give us as 2, and 0 times who cares is 0, so 3 times 6 minus 10, that's minus 4. That's our answer. Okay, this one's pretty easy. We just had to basically figure out how to use the pieces of information that they gave us. Okay, otherwise the setups were pretty easy. Like here, the setup was very simple, but we just had to use properties of integrals to be able to use this piece of information. This we could integrate. This is an improper integral. We just had to have good notation to evaluate. And then this, again, we had to figure out which pieces of information to use. And this is the integration by parts because it's a product of two things. So integration by parts was probably a good candidate. And we purposely chose dv as f prime so that we can get v as f so that we can use this piece of information and also this one as well. All right, please give this video a like if it has helped you in any way. And hopefully I'll see you in another video as well. Bye.